You are standing in front of a vending machine. You are not hungry, not really. You ate lunch 2 hours ago, and yet something in your body is pulling you toward the bag of chips behind the glass, insisting, quietly but persistently, that you need it. You know it is not good for you. You know this exact craving has happened 100 times before, and still, more often than not, you give in. Why does a species smart enough to build vending machines remain almost powerless against what is sitting inside one? Think about the last junk food craving you had. Was it for a plain piece of chicken breast, a bowl of steamed vegetables? Almost certainly not. It was for something salty, something sweet, something fried, something rich with fat. Your body did not randomly generate that craving. It inherited it from ancestors who lived in a world that no longer exists, and that inheritance is at the center of one of the strangest collisions in human history. To understand why, we need to go back roughly 2 million years, long before agriculture, long before cities, long before anyone had ever tasted refined sugar. For nearly the entire span of human evolution, calories were scarce and unpredictable. A piece of fruit might be available for a few weeks a year. Fat-rich foods like nuts or the marrow inside animal bones took real effort and risk to obtain. In that world, a brain wired to crave sugar, fat, and salt intensely was not a flaw. It was a survival advantage. An evolutionary biologist named Daniel Lieberman has spent much of his career studying exactly this kind of mismatch, the gap between the environment our bodies evolved for and the environment we actually live in now. Lieberman's research argues that many of the health problems we consider modern, obesity, type 2 diabetes, heart disease, are not new diseases in the sense of being novel biological malfunctions. They are old biological programs running exactly as designed, just inside a completely different world than the one that built them. Here is the logic behind the craving itself. Sugar in the ancestral environment meant ripe fruit, a reliable source of fast energy, available only briefly before it spoiled or was eaten by something else. Fat meant a dense, efficient energy source, critical for surviving lean seasons when food was hard to find. Salt was essential for basic physiological function, and historically difficult to obtain in large quantities. A brain that craved all three intensely and that made a person feel a rush of pleasure upon finding them was a brain that pushed its owner to seek out exactly the resources most likely to keep them alive through famine, migration, and hardship. Crucially, in that ancestral environment, there was a built-in braking system, scarcity itself. You could crave sugar as intensely as you wanted, but there was only so much ripe fruit in a given season. You could crave fat, but hunting or foraging for it took enormous effort with no guarantee of success. The craving and the difficulty of satisfying it were locked together. One kept the other in check. Now fast forward to the 20th century, and a very different kind of expert enters the story. Not an evolutionary biologist, but a market researcher and psychophysicist named Howard Moskowitz. In the 1970s and 80s, Moskowitz was hired by major food companies to help optimize their products, and what he discovered would quietly reshape the entire food industry. Moskowitz found that for any given food, there exists a specific, measurable combination of sugar, fat, and salt that produces maximum pleasure in a human taster, a point beyond which adding more of any ingredient actually makes the food less enjoyable, not more. He called this the bliss point. Using extensive taste testing data and statistical modeling, food companies could now engineer products that hit this precise peak of craveability with mathematical precision, not by intuition, but by rigorous, repeatable science. Think about what this means. The ancient braking system, scarcity, the sheer difficulty of finding concentrated sugar, fat, and salt in nature has been completely removed. In its place is a system actively engineered to maximize craving, sitting on a shelf, available in unlimited quantities, 24 hours a day, requiring no effort to obtain beyond walking to a vending machine or a convenience store. Your brain, however, has not caught up to this change. It is still running software built for an environment of scarcity, an environment where finding something this calorie-dense and pleasurable was rare and valuable. When that same brain encounters a food engineered to hit its bliss point perfectly, and encounters it in unlimited supply, it responds exactly the way it evolved to respond to a rare, valuable resource. It says intensely and insistently, "Get more of this." More recent research has pushed this understanding even further. A researcher named Tera Fazzino, working more recently than Moskowitz, set out to formally define what she calls hyperpalatable foods, foods engineered with specific combinations of fat, sugar, and sodium that exceed thresholds found rarely, if ever, in whole natural foods. Fazzino's research team analyzed thousands of packaged food products and found that a striking majority of them met these hyperpalatable thresholds. foods combining fat and sodium together or fat and simple sugars together, in ratios essentially absent from anything you could forage or hunt in nature. This is a crucial distinction. A ripe mango is sweet, but it does not also carry a dense load of fat. A wild game animal carries fat, but not alongside a concentrated hit of sugar. Nature rarely bundles these reward signals together in the extreme combinations food science now can. Hyperpalatable foods do exactly that deliberately, stacking multiple ancient reward triggers simultaneously, which is precisely why a single potato chip so rarely satisfies on its own. There is a reason the craving does not shut off after one serving the way ancestral scarcity-adapted hunger once did. Fazzino's research and related work in this area suggests that hyperpalatable foods can partially bypass or blunt the body's normal satiety signals, the internal cues that would ordinarily tell you that you have had enough. When fat, sugar, and salt appear together at engineered intensities your evolutionary history never prepared you for, the usual stop signal arrives late, weakened, or sometimes barely at all. There's another thread to this story worth pulling, one that goes beyond craving itself and into how efficiently your body stores what you eat once you do give in. In the 1960s, a geneticist named James Neel proposed something called the thrifty gene hypothesis. Neel's idea was that populations who survived repeated cycles of famine throughout history would have been naturally selected for genes that stored fat with unusual efficiency whenever food was available, a biological insurance policy against the next inevitable famine. A body that hoarded calories aggressively during good times was a body more likely to survive the lean times that reliably followed. For nearly all of human history, this was a brilliant adaptation. Feast, when it happened, was always followed by famine. A body that banked extra energy as fat during a feast was simply preparing sensibly for what history had always guaranteed would come next. The problem, obviously, is that the famine half of that equation has vanished for a large portion of the modern world, while the feast half is now permanently available, all day, every day. The thrifty gene keeps doing exactly its job. It is simply doing that job in a world that no longer asks for it. This connects directly back to what is happening at the level of brain chemistry itself. A neuroscientist named Kent Berridge, who has spent decades studying the brain's reward circuitry, drew an important distinction between what he calls wanting and liking. Wanting is the drive, the craving, the pull toward a specific food, driven largely by dopamine circuits in the brain. Liking is the actual pleasure experienced once you consume it. Berridge's research found that these two systems, though closely related, are not identical, and hyperpalatable, engineered foods appear to trigger the wanting circuitry with disproportionate intensity relative to how much genuine liking or satisfaction they ultimately deliver. This helps explain a very familiar feeling, finishing an entire bag of chips and feeling not particularly satisfied, yet still fully consumed by the craving the entire time you were eating them. The wanting system got exactly what it was engineered to demand. The liking system was left only partially answered. None of this means you are somehow broken, or lacking willpower, or uniquely susceptible compared to other people. It means your reward system is functioning exactly the way 2 million years of evolution built it to function, responding appropriately to a stimulus that itself is entirely new, engineered specifically, whether intentionally or not, to exploit exactly that ancient wiring. The mismatch is not a personal failure. It is a structural one built into the gap between an ancient brain and a completely modern food environment. It is worth putting a specific timeline on how quickly this mismatch actually developed. For nearly 2 million years, human reward circuitry evolved gradually alongside genuine scarcity. Then in barely the last 100 years, and I blink on an evolutionary timescale, industrial food processing, refined sugar production, and large-scale agriculture converged to make calorie-dense, engineered food available to enormous populations essentially overnight. From an evolutionary standpoint, this happened so fast that it is almost meaningless to speak of adaptation at all. There has not been remotely enough time for natural selection to recalibrate craving intensity, satiety signals, or fat storage efficiency to match this new reality. You are quite literally running ancient hardware against a brand new environment that arrived far too quickly for biology to keep pace. But it does change what you are actually fighting against. You are not failing to overpower a simple lack of discipline. You are contending with a reward system perfectly calibrated for a world of scarcity, now facing off against a food science industry perfectly calibrated to exploit that exact calibration in an environment of total abundance. Knowing that distinction will not make the vending machine disappear, but it might change how you think about yourself the next time you find yourself standing in front of one, hand hovering near the glass, feeling a very old, very human craving being pulled by a very modern hook. So the next time you're standing in front of a vending machine, not truly hungry, and yet strangely pulled toward the bag of chips behind the glass, understand exactly what is happening inside you. You are not weak, you are ancient. And the thing calling out to you from behind that glass was built, quite literally, by scientists studying exactly how to speak your ancestors' oldest language.